In this video, I'm going to be teaching you JavaScript as fast as possible. I'm going to go through all of the fundamentals, everything that you need to know to be fluent in the language, and I'm going to cover it as quickly as I possibly can. That means I'm going to talk quickly, just like this. I'm going to skip over stuff that I know you already understand, like if statements, while loops, for loops, or at least cover them super quickly. And I'm going to try to give you the most efficient resource to pick this up as quickly as possible. Now, with that in mind, this is designed for experienced programmers. You don't need to be an expert, but you do need to have written code before, because I'm not going to be explaining basic concepts that I know are going to bore you and that you already know. With that in mind, let's get into this. Let's learn JavaScript. And if you want another great resource that you can use alongside this video, then check out this free guide from HubSpot on an introduction to JavaScript. This guide will help you learn about data types, variables, object-oriented programming, and a lot more. It's ideal for beginners or anyone who wants to refresh their JavaScript skills, and I've left a link to it in the description. And the best part is that it's completely free. Now, one of my favorite parts of this guide is the section on object-oriented programming, because that's a little bit tricky to figure out in JavaScript. Overall, JavaScript alongside CSS and HTML is essential for web development, adding interactivity and advanced functionality to websites. Mastering it equips you to handle various web tasks and build engaging applications, providing a solid foundation for future growth. A big thank you to HubSpot for providing this guide and tons of others completely for free and for sponsoring today's video. Now let's get into it. So I'm going to begin here with a really quick summary of JavaScript, and then we're going to get right into the code. All of the topics will be available from the video player down below, and you can change the playback speed if I'm talking too quickly or too slowly. Now, JavaScript is really the language of the web. It's used all over the internet, pretty much all over your browser. Right now, you probably have tons of JavaScript running on your computer. In fact, you do if you're watching this video. And if you want to build interactive user interfaces, it's really the language to go with. Even if you don't plan on becoming a front-end developer, it's a great language to learn because it allows you to make more interactive applications and to actually see what you're doing. For me, I'm mostly a Python developer, but I learned JavaScript so that I had that complementary language and I could build the front end as well as the back end of my applications. Now, as much as JavaScript is typically used in your browser, you can also use it on the back end. And in this video, I'm going to show you a few different methods for running JavaScript directly in your browser, as well as using Node.js, because it is becoming more popular as a back end or full stack language. Overall, JavaScript is a bit of a weird programming language, as you're going to see in this video. There's a lot of kind of weird things that go on, some nuances and some weird things with typing that you won't see in other languages. So make sure you stick around and you pay attention to those subtle points, because it's definitely not intuitive. Anyways, that's a little bit of a brief on JavaScript, and I do just quickly want to tell you, I did just launch a newsletter. For any of you guys that sign up, I'm giving away a free guide on how to make money from coding. You can simply click the link in the description and in the pinned comment, sign up, you'll get immediate access to that guide, and you're also going to get coding challenges, project ideas, stories, tips. I promise it's going to be valuable. We've already got 1,000 people there. Join up from the link down below, and now let's get into JavaScript. Okay, so let's go ahead and dive in. Now, the first thing I need to show you is how we run and execute JavaScript code. Now, you can use any code editor you want if you want to follow along with this video. I'm just going to be using VS Code, and I'm going to start by showing you how we run JavaScript from our browser. So because JavaScript works on the web, we don't need to download anything to run it. We can just run it directly in an HTML file, or we can use Node.js, which I'm going to show you in 1 second. So let's say you have a simple HTML file like this. If you want to execute JavaScript code, you can just create a script tag at the bottom of the body. I mean, really, you can go anywhere, but typically it goes at the bottom. And you can write something like console.log hello world, really any valid JavaScript code. And if you want to see the output of this code, what you can do is simply open this in your browser. Any browser will work. So I'm going to open this in my file explorer. I'm going to open index.html. You can see that this is open. I'm going to right click on my page, go to inspect, go to console, and you'll see that we get hello world. Okay, so that's how you can view the output of the JavaScript code. Obviously, you can also affect the DOM, so any of the stuff in the HTML using JavaScript. Now, this is the first way, just directly embedding it inside of your HTML, but sometimes you want to reference an external file. So for example, I can create a script.js file. Whenever you're writing JavaScript, it ends in .js. We can say something like console.log script.js. And now what I can do is I can actually bring in another script tag. And this time, rather than writing the code directly inside of it, I'm going to say my source is equal to, and then the name of the file, which is script.js. Now you also can specify the type here if you want, which is equal to text/JavaScript. You don't need to do this, but you can. And then if we come here and we refresh and we go inspect, and let me just make this a bit bigger so we can see it, and we go to console, you'll see that script.js and hello world are being printed out. Okay, so this is how you run it on the web. These are kind of the two main ways to inject it inside of your HTML. And you can also reference remote files, so something that's maybe not on your own machine from like a CDN or some kind of server. However, a lot of times we just directly want to run JavaScript, and we might not want to do it on the web. If that's the case, we can actually run JavaScript in a backend environment using something known as Node.js. Okay, so I'm going to show you how that works. First thing we need to do is download Node. Okay, so this is the download. You can get it from the link in the description or just nodejs.org. Download Node.js, make sure it's in your system path. And then what you can do is you can open up your terminal, make sure that you restart the terminal if you just downloaded it. And when you're in the same directory as your script, you can simply type node and then script.js. This is going to execute it in a backend environment. This means that you're not going to have access to the DOM, for example, because it's not connected to an HTML file. And there's a few restrictions on what you can do because, again, you're not running this in the browser. You're running it in kind of this backend environment. Anyways, you can see that when we executed this, it printed out console.log. And from now on, that's what I'm going to be using because this isn't a web tutorial. This is just simply a JavaScript tutorial to go through all of the syntax. Okay, so now we are moving on to console output and comments. Quickly, comments are simply ignored when your code is running. To have a single line comment, you can do 2 slashes. To have a multi-line comment, you can have a slash and an asterisk, and then end that with an asterisk and a slash. Now, when it comes to outputting things to the console, there's many ways to do that, but here are the 3 most common. We have console.log, which is just a normal logging message. We have console.error, which will give you kind of that red error text. We have console.warn, which will give you yellow warning text. If I run this, you can see that we get our first log, our error, and our warning. Now, if you want to output something that's a little bit more complex and contains something like a variable, let me show you how we do that. We're going to cover the types of variables, so just bear with me. But let's say I have const v is equal to something like 64, and I want to embed this directly inside of a string. There's a way that I can do that using backticks. So what you can do is you can do a set of ticks or backticks. This is on the same key as the tilde or the squiggly line. And when you do this, it allows you to embed variables using a $sign and then a set of braces. Here I can do something like v is equal to, and then v. That's just going to take this value, automatically convert it to a string, and then print it out, similar to something like an f string in Python. When I run this, you can see that we get v is equal to 64. So if you want some special strings with variables inside, then make sure you use the backticks. If you try to do this inside of a normal set of quotation marks, it's not going to work, and it's just going to give you the regular string representation. Okay, that's it. Let's move on to the next section. So now we're moving on to collecting user input. Now this method is specific for the backend. This will not work if you run this in the browser. To collect input in the browser, you can use a prompt function, and the prompt function will just automatically kind of pop up a prompt on the web page and allow you to type something in. This is going to be different, and this only works for the backend. So just keep that in mind, but I do want to show you because a lot of people want to do this. Okay, so in order to collect user input, there is some advanced JavaScript we can write, but instead what I'm going to do is install a NPM module. Now, NPM is the Node Package Manager, and this is something that you can use in your JavaScript projects in order to handle different dependencies. So what I'm going to do is create a new NPM project by typing npm init-y. Do this in the directory that you want to initialize the project inside of. What this is going to do is create a package.json file, which will manage the different dependencies and their versions and a bunch of other stuff, but we don't need to worry about it too much. Now, all we want to do is we want to install the package that allows us to really easily collect user input, and that is called prompt-sync. So what I'm going to do is type npm install prompt-sync. This will work once we have the package.json here. Gonna press enter, and you're gonna see that what will happen is it will install this, it will create a package lock file, and it will create this node modules directory. Okay, now if I want to use the prompt sync module, what I need to do is the following. From my script.js file, I'm gonna write const prompt, const is a type of variable, we're going to look at that 1 second, is equal to require. This is how you import something. And then we're going to import what we want, which is the prompt sync. And we're going to call this because it actually returns a function. You call the function and that actually gives you a new function that allows you to collect user input. I know this might be a bit confusing if you've never seen this before, but now I can write prompt and I can say, type something. And we can store this in a variable, for example. So I'm going to say const v is equal to this and console.log v. Okay, let's save and let's run. And you're going to see that if I type something like hello world, then it prints out hello world. Okay, that's how you collect user input. We're going to look at this more later. The point is you import prompt, you use the prompt function, then anything that the prompt function returns will by default be a string, and then you can use the string, you can print it out, you can handle it however you want. So that's how you collect user input from the backend without having to write any super complex code. Okay, so now we are getting into variables and data types. So let's begin with our primitive data types, which are the most basic data types in JavaScript. Now those are the string, the Boolean, the number, the undefined, if we can type that correctly, and the null. And while we're here, you'll notice that at some points you'll see semicolons. You don't actually need these in JavaScript, but they are a line terminator and you can use them to finish off a line. So if you're familiar with semicolons, you can use them in JavaScript, but you don't need them. If you forget them, it's not going to give you an issue. Anyways, we have string, Boolean, number, undefined, null. Now a string is anything that's surrounded in double, single quotes, or backticks, okay? These are all valid strings. The Boolean is simply the true or false value in lower cases. And notice that this is a reserved word and you can see that it's being highlighted in a different color. A number is any number, whether it's a decimal or a whole number. So I have something like 12.34, that's a number. I have something like 8, that's a number. -9, 0, these are all numbers. Next, we have undefined and null. Now, undefined is a type, but it's also the only valid value within that type. So undefined is undefined. That's the type of this value. I know it's a little bit weird in JavaScript, but this is the type as well as the value. It's just one word, undefined. Same thing with null. This is the type as well as the value. And the difference between null and undefined is that you use null when you want to explicitly set something as nothing. Undefined is more used when you haven't yet assigned a value to something, but you will later on. Whereas null is used when you explicitly want to define that this thing is empty or non-existent. Null and undefined are not the same thing. They are different types and different values, okay? We'll talk more about those later, but understand these are the 5 basic primitive types. There are 2 more. We have big int, which is used to store big integers that cannot be stored in the number type. And we also have the symbol primitive, but we're not going to talk about those now because they're not really used a ton. At least they won't be used in this tutorial. Okay, so now let's move on to variables. In JavaScript, there are a few ways to define variables. The first way is to use the var keyword. The way you do this is you write var, you then write the name of the variable, something like x, for example, you put an equal sign, and you can assign this to whatever you want. Now, when you write your variables, the same naming rules apply as in many other languages. You cannot start this with a number, you cannot contain any spaces. The convention is actually to use camel case rather than snake case like you would use in Python, and you need to make sure you don't have any special characters like an asterisk or something in the variable name. Now this var keyword is a variable that can change, so later on if I want I can say hello world is equal to world. This is perfectly valid and it will not give me any issues. Now this var is actually what's known as function scoped and it is hoisted. We're going to talk more about that in a second because it's a bit more advanced, but keep in mind that the keywords I use do have some different properties even though they might seem like they're the same. Okay, so this is the first way to declare variables using var. The next way is to use the let function, or the let keyword, sorry. The let keyword works similar to var. It allows you to declare a variable that can be changed later on. So if I do something like let x equals 5, and then I say something like x equals 7, this is perfectly valid. I can do that with x. I can even say something like x plus equals 1. Okay, all good to go. All right, the next way is to use the const keyword. The const stands for constant, and when you declare a variable here, you cannot change this later. So if we do something like const velocity is equal to 34, I cannot change the value of velocity. This is a constant. If I try to redeclare it or to modify it, I am going to get an issue. Now, if this stores a mutable type, something like an array, which we'll talk about later, you can mutate the array, but you cannot reassign a new array to this variable because it is a constant. Now quickly, let's cover the main differences between var, let, and const. Now let and const are block scoped. What that means is that you can only access this variable within the block that it's defined in. So for a quick example, if I say if true, and then I define this variable x inside of here, I actually cannot access x outside of the block or before it's been initialized. So if I try to run this code here, you'll see that I actually get an error, and it says reference error x is not defined because this is only available within this current block. Same thing applies with const, okay, just inside of this block, and I also cannot access it before it's been initialized. So if I try to access it here, I'll get an error as well. Now this differs with var. So if I take var and I change x to be var rather than let me just get rid of this so it's a bit more clear. You'll see now that when we save our code, clear and run, that there's no error and we're able to access 3. The reason why we can access x here is because this is function scoped, okay? So there is a difference between var and let. Because this is function scoped, I can access it anywhere within the function that it's been defined inside of, and if it's not inside of a function, I can access it anywhere in my program. Okay, that's var. Now another interesting thing happens if we write this in a function. So if I do something like function test, okay, and then I say console.log, and we log x, and we say var x is equal to test, and then we console.log x again, and we call our misspelled function. Okay, I guess it's going to be called test now. If we clear and run, you see that I actually don't get an error when I try to access x before it's been initialized. That's because with var, all of these variables are actually hoisted to the top of the function, which means once they're declared, they'll actually be available at the beginning of the function, but they just won't have their initialized value yet. So we can still access x and we can use it at the top of the function. It just doesn't yet have the value test until it's been initialized. This is different from something like let. If we change this to let x, you'll see that now we get an error because let values are not hoisted to the top of the function. This is a bit more of advanced usage. You don't need to understand it too much, but just know that let and const are block scoped and var is function scoped. Okay, so now we're moving on to arithmetic operators. Now in JavaScript, we have the same arithmetic operators you're probably familiar with most other programming languages. We have the addition, subtraction, division, multiplication, exponential, modulus, decrement, and increment. We also have the ability to do something like plus equals, minus equals. We can even do asterisk equals or multiply equals and divide equals like this. Same thing with mod actually as well. So we can do all of these different operators, but the main thing I want to focus on here is what happens when you perform operations with different types, because this is a little bit weird compared to other programming languages. So let's define some variables. Let's say we have const x is equal to 6, and we have const y is equal to something like 7. Now, if we take a console.log and we add x plus y, you might assume that we're going to get an error because these values are different types, like we would in many other programming languages. However, notice that we actually get 67. Now, why are we getting 67 here? Well, obviously 6 plus 7 is not 67, but what happened here is we actually converted the x into a string in order to add these values together. Now, let's see what happens if we add the y plus the x, and you see that we get a 76. Now, the reason why we get this weird result is because in JavaScript, we perform something known as a type coercion. Now, I might be mispronouncing that, but essentially it's an implicit type conversion when you try to do arithmetic operators on values that are different types. For example, when we use a number and a string, by default, we will convert the other number or the other operand into a string and then apply a string concatenation, which simply combines the two strings together, hence why you're getting 67 and 76. Okay, now same thing kind of applies here if you do something like true. Okay, so if we try to add 6 plus true, notice that we actually get 7. It's not necessarily intuitive, but true is kind of equal to 1. So when we add 6 plus true, we end up getting 6 plus 1 because JavaScript applies this type coercion or this type conversion for us, and we get 7. Now, if we try to do 6 plus false, you can probably guess what we're going to get. We simply get 6 because, well, we are now adding 6 plus 0. If we change this to something like hello plus false, and then we run this, notice you get false hello, okay? So JavaScript applies this type conversion for us automatically. It is not always intuitive, so you need to be careful when you're performing arithmetic operations with values of different types. Now, just to show you a few more weird examples, let's have a look at these. So here's an example where we have a numeric string and actually a number type, and we try to perform an operation other than a concatenation, so something like a multiplication. Now, when we use this type of arithmetic operator, JavaScript will actually try to convert any of these strings into a number. So you'll see that what happens when I run this is I get 246. Now, same thing if we do something like a division, you'll see that we get 61.5. We can look at what happens if we use the subtraction as well, and you'll see that now we're getting 121. So again, when we use some operator that's not the concatenation or the plus, JavaScript will try to convert any of these strings into a number and then perform the arithmetic for us. Now, there's some weird things that can happen. For example, if this is a non-numeric string and I do something like, hello -2, rather than getting an error, we simply get not a number. The reason we get that is because we use this arithmetic operator. We attempted to convert x into a number. This is not a number, so instead of giving us an error, it actually gave us the type of nan, okay? So this is a value or kind of a type that you can consider not a number, and you can actually check if something is nan, which we can look at later on. Anyways, JavaScript is a weird programming language and there's a lot of nuances to go through, but I'm trying to show you that kind of weird stuff happens when you perform these type of arithmetic operations on things that are not the same type. Anyways, to avoid this, we want to look at type conversion. So how do I convert values into the correct type so that we don't get these issues? For example, maybe I do want to add x plus y, but I don't want this to be a concatenation. I want this to be a number. Well, if that's the case, there are multiple ways that we can convert a string to a number, which is pretty common. The first way is to simply wrap this with the number, kind of constructor here, okay? So what I can do now is I get the correct value because we're able to convert this directly into a number. Even if this is something like 2345.8, this will still work because remember, number works with decimal values as well as whole numbers. Now, another thing that we can do is we can use the parse int, okay? Now, parse int works a little bit differently, and this will even allow us to do things like convert pixel values into integers. So if I run parse int, you can see that what it did is it grabbed just the 2345, it ignored the px because it parsed the integer component of whatever we typed in or whatever we gave to this, okay? We also have the ability to parse float. So if you want to grab a floating point value, we can change this now to something like 0.4, and you'll see that now we get the correct value. Perfect. Now, if we want, we can also convert something like a Boolean value. So I can say, number true and convert this into a 1. That's going to work. And same thing works with false. Okay, so that's how you convert to a number, but how do you convert to a string? Well, to convert to a string is pretty straightforward. Let's just change this back. Now, if I want this to be a string, I can use the string constructor on my x. Okay, and now you're going to see that we get the string concatenation. I also can do something like this, where I take x plus, and I can just add a string to it, okay? So if you just add a string to a number, even if it's an empty string, it's just going to convert it for us. You can see that now we're getting the string rather than the number typing out. And we also have the .toString method, okay? So we can do .toString, and this is going to convert the number to a string, and we know that it's a string because it's printing in white, not in yellow. Okay, that's pretty much it when it comes to the conversions. Obviously, there's a few other methods you can use, but that is how you go from number to string and string to number, and what happens when you use different types with arithmetic operators. So now we're moving on to comparison operators. Now, similar to other languages, we have the equality operator. We also have the strict equality operator. This is known as the loose equality one. We're going to talk about that in a second. We have not equal to, the not equal to strict equality operator, less than, greater than, less than or equal to, and greater than or equal to. Now, I imagine you know what most of these do, but the one you probably have questions about is the triple equal sign and the double equal sign with the not. So we're going to talk about those because that's the most important concept to understand in JavaScript. Okay, so this here is known as the loose equality operator. And what this does is perform the type coercion that we saw previously when we try to compare values. So I'm going to show you a few examples so you kind of get the idea here. So for example, 1 double equal to 1. Now again, this is a loose equality, and what that means is JavaScript will attempt to convert the values to the same type and see if they are equivalent. So notice that this gives us true because 1 is loosely equivalent to the number 1 because when converted, they're the same. Now let's try something like true is equal to 1. As you guessed, this is true. Okay, let's try something like true is equal to undefined. You see that that is false. Let's try something like null is equal to undefined. This is an important one to remember. This is true. Okay, so null and undefined are loosely equivalent to each other. Let's try something like null is equal to false. That's actually false, which might not be what you guessed. And a lot of people get this wrong in JavaScript. And that is why JavaScript is such a strange language. Undefined equal to false? No, these are not loosely equivalent. So undefined and null are not equivalent to any Boolean value. So you can see undefined equal to true, that's not the case. It's also not loosely equivalent to false. So be careful when you're doing these loose equivalent checks with undefined and null, because it's not exactly what you think, especially if you're putting this in some kind of condition. Anyways, let's look at a few other ones. We have something like an empty string is equal to 0. That's actually true, okay? Something like an empty string is equal to an empty array. I know we haven't looked at arrays yet, but that is true. Now, another weird one is something like 1, 2 equal to the array of 1, 2. That's actually true. Okay, so you get this weird kind of type coercion going on when you use this loose equality, and this loose equality applies with the not equal to as well. Okay, so it just flips it over because we're applying the not. Now, what is preferred to be used in JavaScript, and what I'd recommend you pretty much always use, is the triple equal sign. Now, the triple equal sign is the strict equality operator, and this is going to check both the value and the type. So it's not going to apply any of those type conversions for you, and you're not going to get that weird behavior you saw before. So if we do something like undefined is strictly equal to null, you're going to see that we get false because now these are not the same type. Something like undefined is equal to an empty string, you see that we get false. Something like 1 is equal to 1, you see that we get false, and then we can even add the not strict here, and you see that now we get true. Okay, so this is the main thing you need to remember. Pretty much always use the strict equality or the strict inequality. Do not use the loose unless you know exactly what you're doing, because you can get some very weird results, and the source of many bugs in JavaScript comes from this loose equality and this loose inequality operator. Oh, and by the way, you get some weird results too if you use something like the less than. For example, the number 1 less than 2 is actually equal to true. We can do the number, for example, 3 is less than 2. You see that we get false. So there is some type coercion that will go on here when you use the less than, greater than, less than, or equal to. So again, be careful and make sure you're applying conversions so that you have the same type on both sides and you don't get some weird results that you're not expecting. Okay, so now we are moving on to the logical operators. Now, the logical operators we have here in JavaScript are the same as always. We have and, or, and not, okay? These are the symbols that you can use, and we'll check both the left and the right-hand side, or we'll check the left or the right-hand side for something that is true, and not will simply flip whatever you have to the opposite. Now, if we do this with Booleans, it's pretty straightforward. If I do something like true and false, and then I grab my terminal and I run this, you see that we get false. If I do something like true or false, you see that we get true. And if I do something like maybe let's flip this, so let's put this in a set of parentheses and I go not true or false, we get false. Now, where this gets a little bit weird is when we use this with types that are not Boolean values. So for example, if I do something like hello or true, you'll see that when I run this, we actually end up getting hello, okay? So it doesn't give us a true or false value, which you might have expected. And the reason for that is because this is a truthy value and loosely equivalent to true. When I do the or here, it's actually using kind of a different piece of syntax in JavaScript and selecting this rather than selecting true to be printed out. Now, if I did something like an empty string or true, then you see that I actually end up getting true. And the reason for that is because this is not a truthy value. Now, if I do something like empty string or false, you see that I actually end up getting false. And what you'll notice is that it doesn't matter what I put on the right side here. This is what I'm getting. So I can do empty string or hello. And notice that now I get hello, okay? So it's kind of checking because this is not a true or false value. It's not a Boolean. It says, is this loosely equivalent to true? If it is, we're going to use this. Otherwise, we're going to use whatever's over here. Now, the and works a little bit differently. For example, I go like true and hello here, because these are not both Booleans, notice that I get hello. What's happening this time is we're saying, okay, if this is true, then we are going to display this, or we're going to choose this. Whereas if I say false and hello, then I end up getting false because this is not true, so we end up not showing this and instead showing this. Okay, I don't want to get into too much detail with how this is working. The point in me showing this to you is that if you are not using Boolean values with your logical operators, you need to be careful because you might get some weird results that you're not expecting due to how JavaScript interprets these logical operators, okay? Again, if we were to flip this and say like not false and hello, now we get hello because this is equal to true. So it's saying since this is true, then we will display whatever is on the right-hand side. You see this a lot when you're working in things like React. Okay, those are the logical operators. Again, be very careful when you're using them if you're not using them with Boolean values. If you want to convert something to a Boolean, you can use the Boolean like this. So you can say, Boolean hello and Boolean, let's go here, like 2 or something. And now you're going to see that we get true because Booleans are on both sides. All right, now we're moving on to conditionals. So simply if, and else. Now, the way that you write an if statement in JavaScript looks like this. You write if, a set of parentheses, some condition, and then a set of braces, and anything that you want to happen goes inside of the braces, like hello world. Of course, just like in other languages, you can write an else if. So we can say else if, false, whatever condition you want here. Console.log, do something inside of here. You can nest these statements if you want. You can, of course, have multiple else ifs. And then when you're done, you can add an else. Okay, so this is the basic conditional block that I'm sure you are all familiar with. Now that's fine and pretty intuitive, but I want to show you a few of the unique things with if statements in JavaScript. So if you're only going to have a single line that you're executing after the if, the else, it doesn't matter what it is. You don't need to have the braces. So in this case, I can write if true. I can have this on the same line. I can have it on the line directly after. But if I just have a single statement that I want to execute, I don't need to add braces. Okay, so same thing if I add the else, like I can say else console.log and then run here. Okay, and let's just make this false instead. And now you'll see that we get run. Okay, so this is kind of a simplified if statement if you just have a single line you want to execute. However, if I try to add another line here, notice it's now not inside of the else statement. It's going to happen in the main line. Even if I indent it, the indentation doesn't matter. You'll see that, well, we get this empty thing printing out. And even if I change this to true, we still get it printing out because this is the only line associated with this kind of naked else. I believe that's what it's actually referred to as. So if you wanted these both inside, then of course you would need to add the braces. Same thing works with else if. Now, another thing that we can do in JavaScript is we can write a ternary condition. This is kind of an inline condition or a one-liner. So let's say const condition is equal to, let's write something like, 2 is less than 3, question mark. Then we'll say, okay, cool. Otherwise, no. All right, so what we're doing here is we're writing some condition. We say, okay, if this condition is true, we're going to take this value. Otherwise, we're going to take this value. So now I need to obviously console.log this if we want to see anything. So let's run this now. And you see we get, okay, cool. If we change this to say false, we will get the else value, which is no. This is known as a ternary condition, kind of, again, a one-liner. You'll see this a lot in different frameworks like React, for example, when you're trying to conditionally render different values. Moving on, we are talking about the switch statement. Now in JavaScript, you have a switch. There are a few properties about a switch that make it a little bit different than if and else ifs, but I'm not going to get into all the details. I just want to show you the syntax. Okay, so if you want to write a switch statement, what you can do is switch on a particular value. So in this case, if I just want to check if value is equal to a bunch of different things, rather than writing a ton of if statements, I can use this switch statement. I switch on the value, and then what I'm effectively doing here is checking each case against the value, and then executing what's inside of this case if this value lines up with that. Sorry, I know that wasn't the best explanation. The point is, the way that I write this is switch, set of parentheses with my value. I open my braces, and then inside of here, I can write some cases. Now, the typical convention is to write something like case, whatever the value is, you put a colon, and then anything after that up until the break is encountered will be encapsulated in this case. Now, even though this is indented and there are no braces, the indentation doesn't matter. So even if I run it like this, it's totally fine. What's defining the beginning of the case is this, and what's ending the case is the break keyword. So if you don't include the break keyword, you're actually going to get what's known as a switch fall through, which I'll show you in 1 second. But you can see right now, if I run this, I get 3 is cool, even without the correct indentation, because value is equal to 3. If we change value equal to 4, you'll see that now we get 4 is not cool. And if it's anything else, we have a default case, which will handle anything that's not one of the cases above. And you can see when I run this, I get okay. Now you need to be very careful because a lot of times people will forget these break keywords. And if you forget the break keywords, you have what's known as an automatic fall through. A fall through simply means that you continue on to the next case because you forgot to break. So I have case 3. if this is case 3, what's going to happen because I forgot the break is my code's going to fall through into case 4 and into the default. And when I run this, you see now I get 3 is cool, 4 is not cool, and okay. Sometimes this is intended, but typically not. And you see that what happened is because I didn't break, case 4 and default were considered part of case 3, which means the code inside of here ran. Okay, now if I add a break back here to case 3, you'll see we no longer get that behavior because we break out of the switch statement, so we no longer consider the rest of the cases. Now let me make this a little bit smaller. If I make this 4, you'll see the fall through is still going to happen here into the default because I don't have my break keyword. So we do case 4 and then we do default as well. So just understand how that works and make sure you include the breaks so you don't get an unintended fall through. So now let's talk about JavaScript arrays. If you want to make an array, you can simply define it using a set of square brackets. This is an empty array, and this is mutable, meaning even if I define this inside of a const, I can still mutate the array because I'm not reassigning it or creating a new array. I'm just modifying the existing array. Okay, so that's an array. Of course, you can initialize this with values. The values inside of the array do not need to be the same type. So I can do something like 1, 2, 3 true. That is totally fine. And there is some more dynamic ways to create arrays. So for example, if I want an array that has 5 elements or maybe even a dynamic amount of elements that I don't know, I can say const arr2 is equal to something like new array, and then I can put 5, or I could put some variable here. It doesn't need to be kind of a static number that I'm typing. Now this is going to create an empty array of 5. So if we console.log arr2, for example, let's bring up our terminal and run, you see that I get 5 empty items. Okay. Now if I try to access an element inside of here, like arr at index 2, you'll see that I simply get undefined because we haven't yet initialized the values. Okay, so that is a way to create an array with a dynamic size. You also can just write it like this or make an empty one. Now, another thing we can do is something like array.from. Now, I don't need to use the new keyword when I do this, and I can pass anything that can be looped through. So for example, I could do something like array.from hello. And what will happen now is I will get all of the characters from hello and assign those as individual elements in my array, as you can see here. There's actually a lot more stuff you can do with the array.syntax. I'm not going to show all of it here, but there is ways to kind of initialize different values, have values counting up and down, a lot of cool stuff you can do with arrays when you're initializing them. Okay, so that is cool, but let's look at a few other properties of arrays. So for example, if I want to access or change an element at a position, I can do something like array2 or array2 at index 0 is equal to, I don't know, let's go with y or something. And then we can console.log the arr2. Let's bring up our terminal and you'll see that we now get this. If you want to access the last element in the array, you can do something like this, .length -1. So let's make sure that's the correct array. When we do that, you see that we get the last elements. You can grab length, and because we're 0 indexing, of course, we need to subtract 1. Now let's see what happens if we don't subtract 1 and we try to access an element that does not exist. You see that we simply get undefined. It does not give us an index error. However, what happens when I assign to an element that doesn't exist? So if I have array2, I go array2 .length, I'm now accessing an index that does not yet exist inside of this array. And in fact, let's even do something crazy and like add 5 to it so that we're going, 6 beyond the number of indexes that we have. And let's make this something like test. Now, take a guess at what's going to happen. When I run this, we need to, of course, print it out, but you can see that we did not get an error. So let's type log on arr2. And notice that we actually get 5 empty items and then we get test. Okay, so if we assign to an element that does not exist, we will create that and we will create all the elements before that that need to exist in order for this index to be valid. Very weird, not something I've seen in many other programming languages, if any. So keep that in mind. Again, a lot of weird stuff, very kind of error-prone language here. Anyways, let's look at a few other methods you want to know. So something like pushing to an array. These, of course, are dynamically sized, which means if you push them, they will automatically be reallocated for you. So if I do something like array.push4 and then console.log arr2, you'll see that it will automatically add this for us. 4 gets added. That is totally fine. If I want to pop an element, I can say arr.pop. What pop will do is remove the last element and return it to you. So when we run, you see that now 4 gets removed. And if we printed out this value, you would see that it is 4. Now we also have the ability to shift an array. So let's look at that. If we say arr2.shift, And notice what we've done here is we've actually removed the first element. Okay, so that's what shift will do, removes the first element from the array and returns it. Now, if we unshift the array and we pass an element like new here, you'll see that what happens is we actually add this to the beginning of the array. Okay, so those are some useful methods to know. Now, in terms of looking for elements inside of the array, we have a few that we can use. So we can say array2 dot and then index of, and I can try to index, for example, O and see where that exists in my array. And notice that we get 4. Now this is going to give you the first occurrence. So it says returns the index of the first occurrence, but we also can get the last index of. So I can say last index of, and let's do something like L. And notice here that we get 3, even though the first occurrence was at index 2. Lastly, we can do includes. Includes tells us if something is inside of the array. In this case, we get true because L does exist. Now, continuing here, I have a few other methods to show you. So let's say we make arr3, and we can actually say arr.concat, and we can concat array2. Now, this is going to return a new array to us that contains the elements from both array1 and array2. And we need to, of course, console.log arr3. And you'll see that when I run this, I now get an array that contains all of the elements from the first as well as the second. Okay, that is concatenating. Now, if I want, I can actually join an array into a string. So I can say arr3 is equal to arr.join, and really this is actually a string. So just go str, and we can join this with, for example, a pipe. And when I run this, notice that now I get a string with this as the delimiter separating all of the elements from my array. Now, another thing that you want to look at is the slice and the splice methods. So let's change this back to arr3 and say arr3. If I want to get a portion of the array, I can use slice. You can see it returns a copy of a section of an array. Both start and end and a negative index can be used to indicate an offset. Okay, we don't need to get into all of that, but you can see that I can specify I want to start at index 1, want to end at index 3, but not include it. And when I print this out, notice I get elements 2 and 3. I'm taking a slice from this array. So now we're going to look at splice. Now, if you want to remove an element at a particular index, for example, I want to remove 2, which is at index 1, you can use splice. Now, the first argument here is the index you want to remove, or the element at whatever index you want to remove. So in this case, I want to remove 2, so I'm using index 1. And the next argument is the delete count, which is the number of elements that you want to remove. So if you just want to remove a single element, you use, for example, 1, 1. And when I run this here, you see that array3 is equal to the removed element, which was 2. But if I print out the original array, you see that I get 1, 3 true because I removed this. Now, if I change the delete count to 2, what will happen is it will start removing at this index, but remove 2 elements, so both 2 and 3. So if I run this now, you can see that we only get 1 and true. Okay, there are a lot of other methods you can use on arrays, but these are the most common, and we'll look at a few more later on, but let's move on to the next section. So actually, I lied. I want to show you a few more advanced things with arrays. The first thing to show you is what's known as destructuring. Destructuring essentially allows you to unpack values from an array. So for example, I have an array like 1, 2, and I maybe want the coordinates x, y. Then what I can do is run this when destructure using this kind of array syntax, and I get the values x and y. This does not work if I don't have that array syntax. I need to have it like this, so I specify what elements I want. Now, maybe this is a bit more complex, and I have 1, 2, 3, 4, and maybe I want x to store this, and I want y to store the rest. What I can do is actually use the spread operator, which is these 3 dots, and what this is going to do is it's going to collect the remaining 3 elements. We could make this more complex if we want, x2, for example. We can make this x2, and you can guess what we're going to get, 1, 2, and 3, 4. We can do nested destructurings. We can make this really as complicated as we want, but that is the basic idea. Now, I want to look at this spread operator because this is also particularly useful. So let's say we call this x, and maybe what I want to do is actually create a copy of x and not have it be the same reference because arrays are mutable. So for example, if I say, const y is equal to x, let's print out x and y, and I do something, like y.push, and let's push hello into here, and we clear and run, you see that we actually have the exact same array because x and y are the same thing. So there's many ways that we can copy the array without having the same reference, but a quick shorthand is to use the spread. Now the spread is these 3 dots. When I put this inside of the array, it's going to copy these individual elements. It's not going to give me a same reference. So now when I look at this, you see that X has not been modified when we made the change to Y. Now this is also useful because I can do something like 1, 2, 3, comma, and then dot, 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 X. And this will essentially concatenate all of the values from X into Y. And when I run, you see that now we get those additional values. Okay, so this is the spread operator. It will grab all of the elements from this iterable or from this array and spread them out inside of this array without reusing the same reference. So we get unique values and we have this kind of deep copy of X. Moving on, we have while loops. Now, pretty straightforward, but we do have the do while syntax as well. So this means I can do something and check the condition afterwards rather than having to check it at the beginning. So here's just one example of a while loop you can write that's a bit different than you might have seen in other languages. But of course, you can write another simple while loop, like I can have, while true here, okay, and then console.log, hello. And then let me just break so that I don't get an error here. And you'll see when I run my code that everything works. We get run and we get hello, okay? So while loop, very straightforward. While, set a parentheses, put your condition, and then you can write whatever you want to do. Now, for some reason, you only have one line in the while loop. You actually can just have a naked while, just like you have the naked for loops. And you can do something like hello world. If I run this, I get the infinite loop, so I need to break out of it. But you get the idea, okay? So you have do while and you have while. That's it for while loops. Now we get into for loops. Now to write a for loop in JavaScript, it looks something like this. You can start by declaring your variable. Typically, you're going to use a let or a var. You cannot use a const because you need to modify this. I'm going to say something like let I equal 0, I is less than 10, and then I plus plus. Notice in this situation, you do actually need the semicolons because you're delimiting and separating the different values. You start with some kind of initialization, you have some kind of condition, and then you have whatever the increment is that you want to apply. Of course, you can do a decrement as well. You can do a plus equals to, you can do really whatever you want inside of here, but this is the structure. Now, if I want to, I can do something like console.log and let's simply log I, and you'll see that we get our values. Of course, it is valid to have the break keyword as well as the continue keyword, and that is a very simple for loop. Where for loops become a little bit more useful is when we're looping through some kind of structure. So for example, if I wanted to loop through my array, I have const array 1, 2, 3, for example, and I want to loop through this, I can use this iterator syntax and go arr.length, for example, and then access arr at index I. And let's get rid of the continue and clear and run, and you see we get 1, 2, 3. Now, of course, you probably already knew that, but what we can do as well is use a different type of syntax where we loop directly over the structure. So I can actually say for, and I can say something like let I of arr or let value of arr, and now I can just print out the value. And what happens now is I get the values inside my array. Now it's probably better if I make these like more unique so you can see that they're not actually the index. And when I run this, you see we get 4, 5, 6, okay? So you can define your variable of some iterable. In this case, I'm going over the array. If I wanted to change this to something like a string, this is fine. And you can see that we can iterate over the string. Works for pretty much any iterable object, whether that's an array, a string, etc. Okay, so that is the for of, but sometimes you want to grab the index as well as the value. So what I can do here is something like const arr, and then I can say arr.entries. When I do this now, what's going to happen is I can grab the index as well as the value, and I can kind of unpack them like this. So now I can print I and value, and you see that we get 0, 1, 1, 2, 2, 3, and 3, 4, the index associated with the value. Okay, so dot entries works specifically on arrays, and that's going to grab the index as well as the value so that you can have both of them. If you don't care about the index, of course, you can just use the normal of syntax. Make sure you use of, not in. In works differently, specifically for objects. If you try to use in, which I always make the mistake of because I come from Python, you're going to get some weird results, so just be careful with that. So now we're getting into objects, which are very commonly used in JavaScript. Now, if you've ever seen JSON before, you've probably seen what a JavaScript object looks like. That's because JSON is JavaScript object notation. Anyways, let's make a few objects. There is a lot of stuff to go through with objects, so keep in mind I'm not going to cover everything, but I'll give you the main kind of features here. So this is an object, anything inside of a set of braces, and objects have properties associated with values. So I can have a property like name, and this can be Alice. I can have a property like age, and this can be 23, and I can even have functions inside of my objects. So for example, I can say, say hello, and this can be a function. I know we haven't looked at functions yet, but we can just define a function, and this can return hello or something like that, okay? So this is perfectly valid inside of the object. Now to access properties of the object, you have two options. You can use the dot notation, so object.age. You can reassign this to something like Tim if you wanted to do that. And you can make new properties by doing something like object.new _ prop, or let's just go with camel case, which is the convention, is equal to a list, whatever. This is perfectly fine. Now you also have the ability to do this using the bracket notation. So I can go object and then name. Notice that I'm doing this inside of quotation marks now, and then I can access the name property. This works the exact same as when I did like this. Now, of course, you can also have objects inside of objects. So I can have like, career or something, and then I can have an object and I can put fields or properties inside of here. And if you want to delete something, you can go something like delete object.career, and now I will remove this property from my object. Objects are very flexible. They are used all of the time, and you'll see commonly in larger programs, you have kind of nested objects, functions, a lot of stuff going on here. Okay, now oftentimes you want to loop through, for example, the keys, the values within an object. So what you can do is use some of these helpful methods. So I can do something like console.log and then object.values, and I can pass my object. When I do this, it will give me all of the values inside of my object. Okay, it's not going to give me the nested ones, just the ones in the first level. Now, if I want to get the keys or the properties, I can do object.keys. That's going to give me all of the different keys that I have, and I can loop through this using a for loop. So I can just loop through keys like this, or I can do something like this. I can say for, and we're going to go let key in obj, and then I can console.log the key. And when I do this, notice that I get all of my different keys. So that's what I was saying. You use in when you're looping through the keys of an object, and of when you're looping through something iterable like an array. Okay, now there's a few other things you can do here with objects. Let's say I have object2, and this has some other fields that I want. Maybe it has, I don't know, hair color or something like black, and some array equal to some value. I don't know, I'm just coming up with random examples here. If I wanted to maybe combine these objects together, what I could do is say const object3 is equal to, and I can actually use the spread operator on both of them. So I can say obj and ... object2. Now what this is going to do is grab all of the different properties and their values and assign that inside of here, and then it's going to do the same thing for object2. So if I decide to print out object3, make this a bit larger and run the code, you see that we get all of the values kind of combined together. Now, if we did have some that were overlapping, so for example, maybe we have another name and this time we change it to Tim. Same thing, if we make this larger now and run, you'll see that what happens is whatever was added second is going to override, right? Because name was already in here, and then we added name again. Because name was added again, we take the most recent value, so we overrid Alice and instead had Tim. Now this also works similarly to the array, where this is going to make a copy of the values, but you need to be a little bit careful if you have nested structures. What I mean by that is, let's look at this. Okay, let's make it a little bit smaller. Let's say I go object3.career.info is equal to, tech or something, okay? And then I console.log object and object3. Just want to show you what we get here, and notice that the career has actually changed in both. The reason why the career changed in both is because career is storing another object, but it's actually storing the reference to that object. So when I used the spread operator here, yes, I did make a deep copy of career, but I didn't make a deep copy of what it was storing, which in this case is another object. So you need to be careful when you're using kind of nested structures and you're using this spread syntax, because now object3 is storing the same reference to career as what is being stored inside of object. There's ways to fix this and some methods that you can use. I don't want to get into too much here, but same thing with array, for example, right? So if I go object and 2 here, dot arr dot push, and we push some value. We can push tech again. Okay, let's print out this time object2 and object3. And notice that what we get here is 1, 2, 3 tech and 1, 2, 3 tech. Okay, so just keep that in mind. If I change hair color in object2, it's not going to change that in object3 because this is a primitive. It's not a mutable type. So we can look at that. So object2 dot hair color is equal to brown, and then we can print object2 and object3, and you see that it's brown here and it's black in this object. Okay, so just be careful when it's storing reference types or things that are mutable, not the primitive values. Okay, last useful thing to look at here is destructuring objects. So for example, I can say const hair color and name is equal to object3. What this is going to do is it's going to grab out these properties and just these properties, even if there's more that are inside object3. And then I can const.log the hair color and the name. Now name is reserved, so it's giving me an error, but you can see that Black and Tim are now coming out of object3. Okay, again, a lot of stuff with objects. The more you use JavaScript, the more you'll learn about it, but those are kind of the main features as quickly as I can go through them. Okay, so now we are moving on to sets. Now, if you want to make a set in JavaScript, you can do something like this. Const my set is equal to, make sure you use the new keyword because we're actually using a constructor here. We're going to say new set, and then you can put values directly inside of here if you want by doing something like, 1, 2, 3. This will now make a set that has elements, of course, 1, 2, or 3, or you can just have an empty set. If you want to add something to the set, you can say mySet.add. You can add a particular value. If you want to delete something from the set, you guessed it, you can use the delete keyword. If you want to see if a set has something, you can say mySet.has. This is O1 time, so constant time if you want to check if something exists. If you want to get the size of a set, you can say mySet.size. That'll give you how many elements are currently inside of the set, and you can iterate over the set using the for loop we saw before. So you can say for const value of my set. By the way, I should have mentioned this before. You don't need to use let when you're doing this. You can use const inside of the for loop. Even though it doesn't seem intuitive, it is fine. And you can say console.log, and you can console.log the value. You get the idea. If you want to clear the set entirely, you can say mySet.clear. And I think that is pretty much it. Lastly, I'll show you that if you have a set and, for example, you want to convert that to an array, you can say const, arr is equal to array like this, dot from, and then you can pass my set, and then this is going to take all the set elements and convert that into an array. Another way that you can do this is you can actually write the array syntax. You can use the spread syntax. You could do something like, new set, and then you could have elements here, or you could just use your set variable. In my case, this is my set. So the spread does not only work on arrays and strings, it also works on anything that's iterable. It has multiple elements. So in this case, a set as well, this spread will work on it. And that's also a way you can make the copy of the set if you want to do that where you don't have the same reference. A few other things you can do with sets, but that's pretty much it. And now we're going to move on to maps. Okay, so now we're getting into maps. Kind of similar to objects, we can map keys to values. They work a little bit differently, but let's have a look at them. Okay, so with our map, this is a way that we can make an empty map. If we want to initialize pairings inside of here, then we can have an array of arrays where we have 2 elements in here. And now we're going to have 1 associated with 1 and 2 associated with the string 2. If we want to add something to the map, same as before, we can say my map. This time it's going to be .set. And we can set, for example, 4 to 4. Okay, so you're defining the key and then the value. If you want to delete something, you could say delete, and then you just specify the key that you want to get rid of. And if you want to get a value out of the map, you can say mymap.get and something like 4. If that exists, it's going to give you the value. If it doesn't, it's going to give you undefined. If I do 1, for example, it's going to give me the value of 1. Okay, if you want to see if something exists inside of the map, you can say mymap.has. You can check if the key 1, for example, exists in there. And if you want to grab the size of the map, you can use the .size property, same as the set. If you want to loop over the map, you can do something like for const, and then you can actually use key, comma, value of my map. In this case, you don't need to add any special method. By default, it's going to give you both of the values, so key and value, and you can access them and use them as you want. If you just want the keys, for example, you can use .keys, and now you're just going to say for key. If you just want the values, you can say values, and of course, you're going to change this to correspond to that and be values. If you want to clear the map, so let's go down here, you can say my map.clear, and I think you get the idea. Now, if you want to convert the map into an array, you could say const arr is equal to array.from, and then my map. When you do this, it's going to give you an array that looks like this, where you're going to have arrays nested inside of arrays, and each interior array is going to contain the key and then the value. That's pretty much it when it comes to maps. Now let's move on. Now we'll quickly look at error handling in JavaScript. So you do have these try catch blocks. Every try must be associated with a catch. The catch can be naked, so you don't need to have the error inside of here. You can just have a catch like that if you want. But if you do want to actually see what the error is, then you can grab this in a variable. You can call this whatever you want, and you can access the variable and grab, for example, the message or any other property that's on it, depending on the type of the error. The idea here is you can try to do something. If this thing fails or some exception is raised, you can catch that, and then of course you have a finally block which will run no matter what, typically to do some kind of cleanup. If for some reason you want to generate your own exceptions, what you can do is you can throw a new error like this, and you can put some message like this is not good, whatever you want, and then you can handle this error however you please. You can also actually extend custom errors, and you can create your own error types. We're not going to get into that because I don't want to cover object-oriented programming, because that's a whole other topic in JavaScript, but this is the basics behind error handling. Try, catch, finally. You want to throw a new error, use throw rather than raise, or what you might use in a different language. Okay, so now we are finally going to get into functions. Now here's the first way to make a function. For example, you can say something like greet, and you can console.log the user's name. Of course, if you want to return something, you can use the return keyword. You can also have a bare return if you want that. Now, this is, of course, a parameter. You can accept as many parameters as you want inside of the function. And if you want to have something like a default parameter, you can do something like age equals 12, and then you don't need to pass it. And if you don't, it's going to be equal to 12. Okay, this is the first way to define a function. There are many ways to define functions in JavaScript, and functions have their own properties. They can be passed around. I can accept, another function here in this function as an argument if I wanted to do that. Okay, so that's one way. We also have a function expression, which you might have seen me use before. I can say something like const greet. This is kind of invalid because this is already called greet, but I can do this. Is equal to function, same thing, name, and then I can just write the function body right here. Okay, so this is pretty much the exact same thing as this, and then I can write the body. Now, another type of function that you'll see, which is, I don't want to say new, but relatively new type of function in JavaScript with ES6, is known as an arrow function. A lot of people think these functions are the exact same. There are actually some practical differences when it comes to scoping, but I will quickly show it to you. So another way to do this is you could say const greet is equal to, and then you've probably seen something like this if you ever looked at JavaScript before. This is an arrow function where here you're defining the parameters. The arrow defines the function body or the direct return. So what I can do is I can have a body and I can just write the function body inside of the braces. Or if I want to do something simple that's just a one-liner, I can do something like name plus exclamation point, and this is directly going to be returned from the function. Okay, so a lot of times when you see the one-liner, what's on this line is just the return statement itself. So whatever is here is just going to get returned from the function. Okay, that is the arrow function. Of course, you can return functions from other functions. So if I wanted to, I can return, some function like this. I don't know why I would do that, but I can. And when I do this, I'm defining now another arrow function. This one just is unnamed. And then if I wanted to call this function, right, I could say greet, and then I would have to call it twice because I call it once with some name, returns a function, I call the inner function, and that would just give me that name back. Okay, I know I'm going fast, but that's the point of this video. Now, we also have something known as REST parameters. REST parameters allow you to accept any number of arguments. So for example, let's get rid of all this and say function, add nums, and then I can say ... numbers like this. And now what I'm able to do is accept any number of arguments. This will come in as an array, and then I can use the array, sum them up, do whatever I want, and return them. Okay, when it comes to returning values, you can return a single value, or you can return multiple in an array and then destructure them if you want to do that. Now that's pretty much it when it comes to functions. Mess around with them. There's a lot of different ways to create them and to use them, and they are used a lot in JavaScript, as you might have guessed. I'm going to talk about that scoping and the difference between arrow functions and normal functions in just a minute, so stick around for that, but let's go on to the next section. So now we're moving on to three very popular functions that are used quite frequently in the JavaScript frameworks, particularly with arrays. That is map, filter, and reduce. Let's look at them. Map function, all this does is apply some function to every single element inside of an array and then give you a new array with the result of that function. This is like a modifier function, right? So you can see that I have numbers.map. This means I'm going to take this and I'm going to apply this function to every single element in this array. So when we get the doubled array, this is a new array that contains 2, 4, 6, 8. Very common to see an arrow function here, and you can see we're just multiplying the number by 2, but you can use a reference to any function that you want. It doesn't need to be an arrow function or defined in line. Now we can also do this when we have an array of objects, for example, if we want to strip out the user's names. See, we have users.map, user.name, grabbing the property from all of the, elements or all of the objects inside of this array. Okay, next we have reduce. Now reduce is typically used when you want to take an array and reduce that down to a single value. It's usually done when you want to do something like calculate the sum, but you also can do this if you want to concatenate values together. You can get as creative with it as you want. Just showing you a simple example here. See, we have numbers 2. We're reducing this. When we reduce this, we have what's known as an accumulator value and the number we're currently considering. The accumulator is going to accumulate whatever value we will eventually return from this reduce function, and the num is the current value in the array that we're looking at. So when I say something like acc plus num, what I'm doing is grabbing the num, adding that to the accumulator, and then returning this value. This value becomes the new accumulator, which is then kind of acted on in the next function call in reduce. Now 0 is what the accumulator value starts at. Make sure you pass something here, otherwise you can get some weird results. And you can see if I hover over reduce, it kind of tells you how this works. You can read through it if you want. Okay, this gives us a sum, so we just print that out. Now the filter function kind of works similarly to the map function, except what it does is just take all the values from an array that match a specific criteria based on some filter function. This function needs to return true or false, or at least a truthy or falsy value. And what we're doing is taking the num, we're seeing if this mod 2 is equal to 0, so if it's an even number or 0. If it is, then we will keep it, otherwise we will get rid of it. So you can see we just have the even numbers now of 2 and 4. A lot of times you will see map applied to an array inside of something like React, and you'll actually see this function returns a component that you're then kind of dynamically rendering on the screen. If you've never worked in a JavaScript framework, don't worry about it obviously, but I'm just showing these to you because you'll see them a lot, again, particularly in those JS frameworks. Okay, so now we're moving on and talking about this keyword. Now this is important because it has to do with how functions differ from arrow functions in their scoping and accessing this variable. Now, if you've ever worked with object-oriented programming before, you might have seen this keyword or self keyword, which is typically referring to the object in which something is acting upon. What I mean by that is I have some function here, right? Greet, that has some function body, and it says, hello, my name is this.name. Now you might infer that what's going to happen here is Alice is going to be printed or kind of put in place. And the reason for that is that we call the greet method or function on this person. Now, when we use a normal function, this is the case. This.name references this object property because we are calling greet on this object. Now this works because this function is going to inherit this keyword based on how it's called. So when I call person.greet on this particular person, the name is Alice, and so this.name is Alice, right? Now, if we had another person and we call this, person 2, for example, and this is Joe, then similarly, right, if I change this to person 2 and I run this code, now we get Joe, okay? Makes sense, right? That's the logical thing that you would expect. Now, the problem is that this doesn't work when we use arrow functions because of how this is inherited. So if I change this to say greet is equal to an arrow function, notice that effectively everything is the exact same, except we're not using a normal function, we're just using an arrow function. But this time when I run it, we get hello, my name is undefined. The reason for this difference here, and let me just remove this comment, is because arrow functions actually inherit this at the time in which they are defined, not when they are called. Now, I know this is very weird and we can get into a lot more complexity, but the idea is that since the arrow function is defined here, what happens is it actually inherits this from the global scope. Now, if it was inside of a function, for example, it would inherit it from the function scope, okay? But in this case, it's in the main line of our program, so it's inheriting this from the global scope. Now, nothing in the global scope is equal to name, so when we print, hello, my name is this.name, nothing happens. At the time of the definition is when this gets initialized, whereas when we call person with the normal function, this is defined based on how we call this function, okay? So just keep that in mind. If you try to use an arrow function inside of the object like this, you're gonna get an error. So anyways, that's kind of it. I know that might not seem super important, but if you are trying to use this keyword, don't do it within the arrow function because it's not gonna have access to this person or to the object it's called within. It's going to inherit this from the scope in which it was defined, which can give you some weird behavior based on kind of where you have it written, especially if you have it inside of something like a function. So now let's move on to promises. Now, to be honest with you, this is not something that is designed to be taught quickly. It is something that a lot of people get confused with and that I would typically recommend watching a longer video on. I'm going to give you a really fast overview because that's what this video is, but keep in mind that this is probably going to be a little bit confusing and you might want to reference kind of a longer, more in-depth tutorial after this quick intro. Anyways, this is a promise. This is used a lot in JavaScript, specifically when you get into larger projects and you're working with those web frameworks. Now, a promise has three states, okay? It has a pending state, it has a fulfilled state, and it has a rejected state. Now, a promise is an object that represents the eventual completion or failure of some asynchronous operation. Now, a promise is used when you don't know how long something is going to take to complete. So like a file operation, reading or writing to disk, something like sending a network request. For example, you send an HTTP request, you want to grab some values from an API, you don't know how long that's going to take. So that operation is typically wrapped in a promise, even if it might not look like that to you. The reason for that is as soon as you send the request, the promise is in this pending state, and then the request either fails or succeeds. If it succeeds, you resolve the promise and you can handle that value. If it's rejected, there's some kind of error or something went wrong, and then you can handle that error. Okay, so this is a promise. You can make your own promises, although you're typically not making them, you're just using them. And when you make a promise, you have to take this resolve and this reject function as parameters. You then have some function, and what you can do is, in this case, we're kind of simulating some asynchronous operation. If the thing is good, so if we got the result we're looking for, we will resolve the promise with some value. Otherwise, we will reject the promise with some error. Okay, now once this promise is created, if I just immediately kind of start using it, I'll probably be in a pending state. The reason for that is that typically the promise takes a certain amount of time to run. So if I just print it out like the value of my promise, it's going to tell me that it's pending because it's probably taking, a few seconds to execute. Now, what we can do is we can kind of use the promise and we can hook into if it's resolved or if it's rejected. So I can say my promise dot then. Now, dot then is what happens if this is resolved. So I'm saying my promise dot then. I'm passing some kind of function, and this function that I'm passing is actually what's going to be called by the promise with this resolve. Okay, so if I pass some value here, and then I console.log the value, okay, and we make this like good, and we make this error like bad, for example, you'll see that when I run my code, okay, that we get good. Now, again, what's kind of happening here is this resolve function is actually equal to whatever the function is that we pass in dot then. If the promise is good, if we get some value, we resolve. So we pass good to this resolve function, which is what we've written right here. We then handle that and we print out the value, okay? Now we also have dot catch. This is what happens if the promise is rejected. So we're gonna take in again our value and just console.log the value. And now if we make this false, okay, so let me change this to false. You're gonna see when I run this that now we get bad, okay? So dot then, we're passing the resolve function. Dot catch, we are passing the reject function. And inside the promise, we either call, resolve, or reject. So we get into the dot catch or we get into the dot then based on what the result of the promise is. Whether it fails, we go into the catch, we can handle the error. If it's successful, we go into the dot then, and we handle the value that was passed to us. The reason why this is an eventual value is typically this promise takes a certain amount of time to run. The dot then and the dot catch are going to wait for the promise to no longer be pending. So whether it's resolved or it's rejected, we're going to get into one of these particular functions. This is usually how you write it, and then handle the result of that promise. Now, as well as this, we can add a dot finally. So maybe we want to do some kind of cleanup operation in console.log always. Okay, so just like we have error handling, we can add the finally, and you see no matter what, whether it's rejected or resolved, always is going to print out. Okay, so that is kind of the first thing to understand with promises. Now I'm going to copy in another example and show you how we can use these to kind of speed up operations. Again, I'm going to go kind of fast here. Okay, so notice here that I have 3 promises. Now, these promises are going to take a certain amount of time to execute. In this case, we're taking 100 milliseconds. In this case, it's taking 500 milliseconds. And if I just waited for these promises to run one by one, then I would have to wait 600 milliseconds for these all to finish. But what I can do, since these are typically not relying on my system resources, but something outside of my control, like an input-output bound operation, is I can run them in parallel using promises.all. So this is where we get into kind of concurrency within JavaScript. So I can say promises.all, promise 1, promise 2, promise 3. This will wait for all 3 of these promises to resolve, and it will kind of start running them all at once. And then we have the dot then and the dot catch, and we can handle all of the results or any errors that occur. So results will be an array of all of the results, okay? And then console.error will be any error that occurred, or actually the first error that occurred from our promises. Now, if we run this here, you'll see that it takes a second and then we get bar. The reason we get bar is that in the set timeout, we called the reject function. But if we call the resolve function here, you see that we get 3, foo, and bar. If we make these a little bit longer, like for example, 1000 milliseconds and maybe 3000 milliseconds, you'll see 1, 2, 3, and then we get our result, okay, because it ran all of them in parallel. Again, there is a lot more stuff that I can show you here, but I don't want to get too complex because I don't want you to feel like this is a full tutorial on promises when there is a lot more to cover with asynchronous JavaScript. I'm just giving you a very, very high level quick overview. And if you want to learn more, consider joining something like my software development program where we really get into depth in this. We cover APIs, HTTP, we talk about creating our own APIs, calling them from React, writing code in Go, a bunch of stuff. I don't need to get into all of it now, but you can check that out from the link in the description. So with that said, guys, that's pretty much going to wrap this up. Quickly, if you want to learn some more advanced JavaScript features, you can look into prototypes and object-oriented programming with JavaScript. They don't really fit nicely into this video, and I don't want to cover them too much in depth because they really do deserve their own video. You also probably want to learn more about asynchronous JavaScript. This is not a full tutorial on that, and what I just showed you really is scratching the surface, and you probably want to understand this in a bit more depth before diving in and writing a massive amount of JavaScript code. Anyways, I wanted to try to teach you the basics as fast as I possibly can. Hopefully you appreciated that. Leave a comment down below with what you thought, and I look forward to seeing you in another video.